Okay, so we're going to talk about significant digits. In essence, this is going to be significant digits part 1. When we talk about significant digits, a little where we're going. The reason we care about significant digits is going to be because of measurement, and we'll talk about that a couple of ways ahead. So just keep, this is kind of some background for you. Now, the main thing to remember is when we talk significant digits, we are typically referring to measurement. By definition, when we talk significant digits, we're referring to something that is not. It never refers to an exact number. That means by definition, what we're referring to is an inexact number. So if we're referring to an inexact number, remember your definitions, that's a measurement. Okay? So when we talk about using measurement, what we're talking about is we're talking about what we need to know. Why do we care whether something is reliable or accurate or anything like that? Well, it has to do with this concept of uncertainty. And when we talk about uncertainty, what we're talking about in science is we are talking about reliability. We're talking about how reliable are the numbers. Are they one of a kind? Can they be duplicated? Because everything in science cares about replication. So uncertainty in science has to do with how valid the numbers are. When you compare these two numbers here, if you look at the top one, the barometric pressure, it has a lot of numbers, doesn't it? So you get the impression that that's a fairly reliable and really accurate number. The mole, on the other hand, we look at this and we have 6.02 times 10 to the 23rd. Now remember the times 10 to the 23rd, that's just scientific notation. Okay? All scientific notation does is allow us to make really large numbers manageable or really small numbers manageable. This is just telling us how many times to move the decimal. It has nothing to do with the number. This is my number. So if we compare those two numbers, this number definitely seems more accurate. Therefore, this number has less uncertainty. Okay, so the more accuracy I have, the less uncertainty I have. That's the point here. So that means when we talk significant figures, again, what we've already established, we said this was an inexact number, then by definition, meaning significant figures only refer to measurements, and by continuation, calculations. And so if we're referring to that, that means that we also need to know what's going on, because we can't do what's known as overstate the accuracy. Okay, think of it as the law of conservation of accuracy. You cannot be more accurate than your least accurate number. Okay, 2 rules. You've probably gone through how to figure out significant digits. You had to worry about the zeros. So if you had a trailing 0 or a leading 0, it had different meanings than a 0 in the middle. Forget that. 2 rules. All you have to know are 2 rules. The Atlantic-Pacific rule. Okay, so notice if the decimal is absent, I start counting from the Atlantic side. Okay, well, that means I start counting from this side, the Atlantic side. Okay, now, a couple of points because this always throws everybody. Okay, we start with the first non-zero number, okay, but numbers are 0 through 9, aren't they? 0 is a number. We know 0 is a number because would you rather have $1 or $100? So we know zeros matter. The point here is where we start counting is with our first non-zero number, but then the kicker, the important part, is we then count all our numbers. Okay, whoops. Let's erase that. Let's highlight it instead. We want to count all the numbers. Okay? Now, for example, if I have something like 3005 versus, let's say I have 3500. Okay? Now, we're going to start with the first one, 3005. I have the decimal is absent, meaning there's no decimal included in the number. I start counting from the Atlantic side. That means I'm going to come over from this side on the left. I'm going to find my first non-zero number. My first non-zero number from the left is my 5. That's my first one. I'm going to count everything after. Well, this is after, this is after, and this is after. So this number has a total of 4 significant digits. Now, if we look at the number below it, Same thing applies. I have no decimal, it's absent. I'm going to start from the Atlantic side. Now my first non-zero number is here. I'm going to count everything after, and now this one has 2 significant digits. Okay, that's all there is to it. Now the next rule then, if that's the Atlantic, then we have to deal with the Pacific. So the Pacific is if the decimal is present. Okay, so present. I'm going to start counting from the Pacific side. That's over here, that way. Again, I'm going to start with the first non-zero number, and I'm going to count all numbers after. So let's do another example. Let's say I have 330.50. Okay. All right, so now, according to our rules, I have a decimal present right there. So I'm going to start counting from the Pacific side, this side. First non-zero number is 3. Everything after, so that's 2, 3, 4. So this number has 4 significant digits. Okay, let's do one more. Erase this. Alright, so let's do another one now. Let's do something like 10.0. Okay, and 42.3. Okay, so again, decimal present, yep. Start on the left side. My first non-zero number is the 1. I count everything after, so this has 3 significant digits. This one, decimal present, Pacific, first non-zero number is 4, count everything after, so I have 3 significant digits in both. That's all you're doing. Now I want you to look at some practice problems real quick. What I want you to do is I'm going to show them to you. I want you to pause the video. When you pause the video, you're going to solve them. I'm going to then you'll start the video and you'll see the answers. You'll see the number of significant digits and the side you should have started to count from. Now, I'm going to point them out to you. Now, see here, so now you should pause, but I'm going to point out real quick. These last 4 are kind of tricky, so pay attention to what you're doing and what information you're given. So pause the video and then answer them and then start the video again. So here are the answers. Now, a lot of these are obvious. The 2, okay, you had a decimal present, correct? So since my decimal was present, I know I had to start from the Pacific side. First non-zero number is 3, so that's 2. Here, 100, decimal is absent, so I'm going to start on the left side. My first non-zero number is the 1. There's nothing after it, so there's only 1. Here, present, Pacific side. Left, first non-zero number is 7. Nothing after it, so we're good. So 3. These ones, now again, remember what I talked about earlier. Whenever you see times 10 to the negative third or times 10 to the 15th, that's just scientific notation. That's irrelevant to the number. This is just telling you where the decimal should be if we wrote out the number, but it's not part of the number. Okay, the only thing that matters in the number is going to be the actual number itself. In this case, 2.34. In this case, 3.0. So there's a decimal present. I start from the Pacific side with the first non-zero number. The first non-zero number is 2. I have a 3 and a 4 after it. That's why this one has 3. Here, my first non-zero number is the 3. There's a 0 after it, so that's 2. So that's why there's 2 significant digits. Now, on these one, it's Atlantic, but you're given this plus or minus. The plus or minus is what we call our uncertainty in science. Okay? This uncertainty in science tells us where we're uncertain to. In this case, plus or minus 10. So I go to the 10 spot. Okay, let me put it in red. I'm going to go to the 10 spot, which is right there. That means that's where I should start my count. So that one actually does matter. 2, 3. I have 3 significant digits. In this case, plus or minus 1,000. So I'm going to go to the 1,000 spot, which is right there. And again, the only reason I know to start there is because of this. So I have 1, 2, 3. So whenever you're given the plus or minus 10 or the plus or minus 1,000, You're actually being given more information. You're being told something specific about those numbers, so we have to adjust what we know about the Atlantic Pacific rule. Okay, as soon as you finish this, work on some of the practice problems, then watch the next video.